Today I'm making an unedited video, and this is a very short video, but if you are designing an amplifier you should know this, because I was dealing with a oscillating amplifier and I kind of solved it. It has very low oscillations and very low distortion. The oscillation is about 0.6%. So basically the oscillations are not distorting the audio signal coming to the speaker. So basically the distortions are less than 0.6%, and the global feedback is trying to correct the audio hard and it corrects any errors. So that's why the distortion is very low and the oscillation is low, because I increased the tail current to 2 milliampere and I'm using 470 picofarad capacitor. So basically, how does this basically reduce the oscillation? Well, increasing the current is because to keep up with the slew rate you want 2 or 4 volts per microsecond of slew rate. Basically, more is better to keep the highs very high or to not smear the highs. So basically 2 milliampere with this capacitor gives you about 4.1 volt per microsecond. And if you are basically using your amplifier for up to about 18 volts, then basically the highs will not distort, they will not smear, and the highs can also basically clip the audio rail. So basically we are increasing the current to keep up with the slew rate, and this capacitor helps in basically smooth the instability. Well, what happens is that this transistor needs very low current, base current, to basically have the half of the supply voltage at the output, because the collector of it sits at 10 milliampere. So it needs very low current, maybe 100 milliampere if the transistor has the gain of 100, which is quite possible. It is also possible that the transistor have gain of 200, but let's assume the transistor has gain of 100. So now there's 100 milliampere here and we have 200 milliampere. Well, what happens is that this transistor can oscillate. So basically there is this capacitor. This capacitor passes very high current at high frequency. So basically it will damp the oscillation hard. So this VS transistor will not oscillate, and only about 100 or 200 microampere will flow through the base, and this basically gives the amplifier a stability point and it stabilizes the amp, no oscillations. But I'm using lower frequency output transistor type P3055, which have frequency transition of 200, basically which has a frequency transition of 2 megahertz. So basically, and it has very high base charge. So basically the transistor itself can add a bit of basically phase shift, which can basically go to the loop and it can start oscillate, but we have provided it a strong stability point. So the oscillations will drop, and it will drop very fast, and there will be not much oscillations, or the oscillation might go away if I will use a faster transistor here. Here I turned on my amplifier. Now the scale you can see is 50 millivolts. You can see a little bit of oscillations, but it is not very high. The other amplifier set has a bit of oscillation. I don't know why, but it is less than 50 millivolts. It is less than that. You can see this is the peak to peak value, but if I set to peak 60 millivolts, which is quite low actually, and the signal can swing from 17 volts peak to peak, which is 5 to 6 volt RMS. And of course I'm using this big SMPS power supply to power the amplifier, and also use capacitors across the transistor to basically provide a reservoir if it hits the base. Basically, if the capacitors are not there, it can trigger the oscillations. And of course use a capacitor in the main amp board, because it is using TIP transistors here, and it also needs current or reservoir to provide the base charge for the output transistor, and decouple the preamplifier board using a resistor and a capacitor soldered across the board with a ceramic on it. Now I'm playing it. Well, I can play something else. I can play a 50 Hertz tone. 50 Hertz. Six volts RMS with 17 volts peak to peak, and if I zoom it a lot you can see the oscillation, but it is less than basically 100 millivolts. Thanks for watching the video. I hope you liked it.